Hi everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing an introduction to nomenclature. So this is brand new information that you have not seen before, so you'll need to take notes on it. Once you've taken notes on it, you'll need to go to my viewpoint and turn them in online. Okay, so let's get started. Nomenclature is a system of naming compounds. So we have two different types of compounds that we're going to be looking at. We have ionic compounds and molecular compounds. So to kind of break it down into the simplest terms, ionic compounds are made up of a metal and either a nonmetal or what's called a polyatomic ion, or it is made up of ammonia, which is an NH4, plus a nonmetal or a polyatomic ion. And then molecular compounds are just anything that doesn't start with a metal or ammonium. So basically, you can have a metalloid plus a metalloid plus a nonmetal plus a metalloid, a nonmetal plus a nonmetal. So we really do need to understand where the metals, metalloids, and nonmetals are on the periodic table. Our metalloids are kind of from boron all the way down, and that's sort of our dividing line. And so everything to the left of that is going to be a metal, and everything to the right of this line is going to be a nonmetal, with the exception of hydrogen, which is also a nonmetal. So if our compound starts with anything that is to the left of boron going diagonally through this metalloid line, then that means that it's probably going to be an ionic compound. If it starts with anything that is to the right of this line, it starts with a nonmetal or one of these metalloids, and it's most likely going to be a molecular compound. All right, so let's first talk about what ions are. So we've talked about these briefly in terms of the number of protons and electrons that an element has. So any group or group of atoms that has a charge is an ion, which means that they have an uneven number of protons and electrons. So we can create ions when atoms gain or lose electrons. So a cation, and this is pronounced cation, not cation. A cation is when we lose electrons. So since electrons are negatively charged, if we're losing negative charge, then our ion is going to end up with a positive charge. Whenever we have a negative ion, that is called an anion, not an anion, anion. So an anion occurs when electrons are gained by an atom. So electrons, again, are negative. So if you add negative charge, then our ion becomes negatively charged. So positive ions are cations, negative ions are anions. Okay, we have two different types of ions that we can talk about. We have what are called monatomic ions and polyatomic ions. The root of both of these words being atom. So mono means one, so monatomic means that's an ion that is made of one atom. All right, so this ion is made up of only one type of element. So we have two groups of elements that we can divide the periodic table into. We have main group elements and then transition metals. So our main group elements are group 1, 2, and 13 through 18, and then our transition metals are everything group 3 through 12. Main group elements only form one type of ion, so it's easy for us to figure out what that charge is going to be. Transition metals can form multiple ions, so to find the charge of a transition metal is a little bit trickier. So how elements form ions is based on the octet rule. All atoms want a completely filled valence shell that has 8 electrons, and atoms are either going to gain enough electrons to get to 8, or they're going to lose enough electrons to go back to 0. So essentially what happens is if we go back to 0 valence electrons, that means that valence shell is now empty and the previous shell becomes the valence shell. So we're going to form ions based on whether it's easier to lose enough to get to 0 or gain enough to get to 8. The only exceptions to the octet rule are hydrogen and helium. Hydrogen and helium, because they're so small, they can only have a maximum of 2 electrons. They'll never have more than that. So just as a refresher, our valence electrons are given to us by the last digit of the group number. So group 1 has 1 valence electron, 2 has 2 valence electrons, and then we skip our transition metals. We look at group 13 has 3 valence electrons, group 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8. Everything in here is a transition metal. So with transition metals, they have transitional valence electrons. So we don't look at their valence electrons. So I know the number of valence electrons by the last number in the group that that element is in for all of my main group elements. All right, so based on the number of valence electrons, I can then figure out what the charge is going to be. All right, so group 1 we said has 1 valence electron, group 2 has 2, 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8. So my goal here is to either get to 8 or drop to 0. So if I have 1 valence electron, I would have to gain 7 to get to 8, but only lose 1 to get to 0. So it makes more sense for me to lose 1 electron than it is for me to gain 7 of them. So if I lose an electron, that makes a cation, which means I'm going to have a positive 1 charge. If I have 2 valence electrons, then I either have to gain 6 to get to 8, or I can lose 2 to get to 0. So 2 is smaller than 6, so it's easier to lose 2 than it is to gain 6. All right, so again, I'm losing, so I have a cation, which means that my charge is going to be positive, and it's a 2+. For these, it doesn't matter whether the plus sign is in front or behind. It can be 1+ or +1, +2, or 2+, whatever you want to write is fine. We have 3 valence electrons for group 13, so I either have to gain 5 to get to 8 or lose 3 to get to 0. So 3 is smaller than 5, so I will lose 3, which gives me a +3 cation, or a 3+. So next we have group 14 with 4 valence electrons. So here I would either have to gain 4 to get to 8 or lose 4 to get to 4. So I can either gain or lose 4. So what ends up happening is that I don't do either. So I don't actually form charges on group 14. All right, next we have group 15 with 5 valence electrons. For 5 valence electrons, I can either gain 3 to get to 8 or lose 5 to get to 0. So 3 is smaller, so I'm actually going to end up gaining 3. All right, so here, since I'm gaining electrons, that's going to give me an anion, and it's going to be a negative charge. And since it's 3 of them, it'll be 3- or -3. If I have 6 valence electrons, I'm either going to gain 2 to get to 8 or lose 6 to get to 0. Gaining 2 is easier, so I'll do that, and that'll give me a 2- or a -2 charge. Group 17 has 7 valence electrons, so here I can either gain 1 or lose 7. Gaining 1 seems infinitely easier, so that'll give me a 1- or a -1 charge. And then group 18 has 8 valence electrons already, so I don't have to do anything. So it's going to not gain or lose. It's already perfect. So it will not form any kind of charge. It'll just be nothing, Na. All right, these are our noble gases. So again, we can see that our noble gases are noble in that sense. Okay, so if we kind of put this on the periodic table, group 1 is a +1, group 2 is a +2, 13 is 3+, 14 is nothing, 15 is 3-, 16 is 2-, and 17 is 1-, and then this is also just nothing. All right, so there is a pattern here. I go +1, +2, +3, nothing, -3, -2, -1. So it's kind of like I'm climbing up. Like I go up 1, up 2, up 3, and then down 3, down 2, down 1. So that's a good way to remember it. You do need to know that group 1 will always have a 1+ charge. Everything in group 2 will always have a 2+ charge. Group 13 is always 3+, group 15 is always 3-, 16 is always 2-, and 17 is always 1-. So that is information that we are going to need to know moving forward. So now let's talk transition metals. Transition metals can usually form more than one type of ion, so they can have more than one charge. They're always going to be positively charged, so metals are always positive, so it's always going to be a +1, +2, +3, +4, +5, or +6. And the way that we know what it is by denoting it using Roman numerals. So we would put the element name and then follow it by the number of the charge in Roman numerals, and the charge is always positive. So for example, here we have lead 2+ would be lead, and then in parentheses, I would put II to represent a 2 in Roman numerals. There are 3 exceptions to this. Silver is always a 1+, zinc is always a 2+, and cadmium is always a 2+. And so we can see here that when we write the names, we don't put anything in parentheses next to it because it's only going to have 1 charge. You don't need to memorize these because this is on your formula sheet on the periodic table that I gave you. So you'll always have this information available to you. You just need to remember to look at the formula sheet to find the charge of these. Lead and tin are both elements that are not in the transition metal zone, as it were. They're over here, but they still behave as transition metals. So tin can be a 2+ or a 4+, and lead can be a 2+ or a 4+ as well. So that's also on the formula sheet to help you remember that. All right, so this is just another summary of our periodic table here with all of the charges that are known all the time. Like I said, everything in group 1 is +1, +2, +3, nothing, -3, -2, -1, nothing. And then zinc is 2+ always, cadmium is 2+ always, and silver is 1+ always. If you want to write this in on your blue periodic table, you can definitely do that, because then you'll always know what the charges are and you don't have to always kind of flip back, and it'll help you learn it if you've got it on that table all of the time. Okay, monatomic ions are 1 element. Polyatomic ions are multiple elements. So poly means many. So if I have polyatomic, that means I have many atoms. These are chemically combined together and collectively have a charge. So each ion has a fixed ratio of elements that can't be changed, and that's what defines it as a polyatomic ion. So again, we're not memorizing the polyatomic ions. These are on the back of your periodic table in the giant chart that is on the top left. So all of our cations are in this column, and there's only 1 cation that is a polyatomic ion. That is NH4+1, and it's called ammonium. So the ratio here is set. I have 1 nitrogen and 4 hydrogens, and collectively these 5 atoms have a +1 charge. The next 2 columns are all anions, meaning they're negative. And then again, our ratio is fixed here. So for example, if we look here, I have Cl with 1 O is hypochlorite, Cl with 2 O's is chlorite, Cl with 3 O's is chlorate, and Cl with 4 O's is perchlorate. So the number of each element that you have in your polyatomic ion matters because it changes the name of our ion. Okay, so this is really all that we need to know about polyatomic ions for the moment. We'll come back around to this when we start writing formulas and naming compounds. How do we distinguish between monatomic and polyatomic ions? So if your ion is monatomic, it's going to be a metallic element when it is in an ionic compound. So monatomic cations are all metallic elements, so they're all those elements that are on the left side of the periodic table. If it's an anion, if it is a negative charge, then it's all the elements that are on the right side of the periodic table. If you're given the name of any monatomic anion always ends with IDE. So if you have fluorine as an ion, we call it fluoride. If you have oxygen as an ion, we call it oxide. So all of your monatomic anions will end with IDE. All right, if we have a polyatomic ion, there's only 1 polyatomic cation, and that is ammonium. It is NH4. If it's an anion, we can most easily identify anions by looking at the ending. If it ends in ITE or ATE, it's a polyatomic ion, and we need to look at our formula sheet to find the formula. The only exceptions to that are hydroxide and cyanide. Both of these end in IDE, just like the monatomic ions do, but when you go to the periodic table, you'll find that there's no hydroxy anything kind of element, and then there's no cyanide type of element. So you won't be able to find anything that looks like either of these on the periodic table. So you flip to the back of your formula sheet, and you find that they're polyatomic ions. So the last kind of thing that we need to be able to do before we can get into the actual nomenclature of everything is identifying the type of compound. All right, so we have sort of a checklist that we can go through. So we ask ourselves 2 questions. Does it start with ammonium or NH4? If the answer to that question is yes, then it is an ionic compound. If the answer to that question is no, then I come to the second question. Does it start with a metal? So I go to my periodic table, I see if that element that it starts with is on the left-hand side of the periodic table. If it is, then it is also ionic, but if it's not, then it is molecular. So that's how we identify whether we have an ionic compound or a molecular compound. And once we've done that, we can go about our rules for writing formulas and naming compounds, which we will learn later. Okay, that's it. This has been another episode of Chemistry with Wikipedia. I hope you learned something, and until next time, keep on chemin'.